Assalamu alaikum student. Today we start ex2.5. Derivative of trigonometric function. While finding derivative of trigonometric function, we assume that x is measured in radian. The limit theorem, sin x over x is equal to 1 and 1 minus cos x over x is equal to 0. These two properties we used to find the derivative. Now derivative of sin x is cos x and derivative of cos x minus sin x, but we prove it by the definition. Let y is equal to sin x. We replace y plus delta y and x by x plus delta x. We move y from left to the right side, put its value sin x. Here we apply the formula sin p minus sin q, which is equal to 2 cos p plus q over 2 and sin p minus q over 2. Therefore the value become 2 cos x plus delta x plus x over 2 and x plus delta x minus x over 2. Simplify these values and then divide by delta x, because we have sin delta x over 2. When we divide by delta x, also divide it by 2 and multiply by 2. Now sin delta x over 2 over delta x over 2, when we apply limit, it is equal to 1. And the next value, cos x plus delta x over 2, we put delta x equal to 0. Therefore it becomes cos x. Now in second proof, y is equal to cos x. We replace y by y plus delta y, and cos x, it becomes cos x plus delta x. We move y to the right hand side. Y means cos x, and in the first value cos x plus delta x, we apply formula cos alpha plus beta minus sin alpha plus beta, sin alpha into beta, and then we taking cos common from first and last value, divide by delta x. Sin delta x over delta x is equal to 1 and 1 minus cos delta x over delta x is equal to 0. Therefore we get the answer, derivative of cos is minus sin x. Next we prove the other derivative of trigonometric functions. Now here we have derivative of secant. We can write secant is 1 over cos. Now we apply here quotient rule, and over d we put these values in quotient rule. Derivative of 1 is 0 and derivative of cos is minus sin x. Now simplify and we get the answer. 1 over cos is secant and sin over cos is tan. Now in this question we have cot x. We can write cot is cos over sin. We apply quotient rule and over d, and derivative of cos is minus sin and derivative of sin is cos. Sin square plus cos square is 1 and derivative of cot is cosecant square x. Now all 6 derivative of sin is cos x, derivative of cos is minus sin, and derivative of secant is tan is cosecant square, derivative of cot is minus cosecant square, and derivative of cosecant is minus cosecant cot, and derivative of secant is secant and tan. All the values which start with the c's, later their derivative is negative. find derivative of tan x. We replace y by y plus delta y and x by x plus delta x. Then subtract these values. We can write tan sine over cos, and then taking LCM, the numerator becomes the formula of sine alpha minus beta. Here we have alpha is x plus delta x and beta is x. Now divide by delta x. Sine delta x over delta x is 1 at the limit delta x tends to 0, and apply the limit in the cos x plus delta x, so it becomes cos square, and 1 over cos square is secant square, so derivative of tan is secant square. Now here we have examples. First is y is equal to cos 2x. We replace x by x plus delta x, y by y plus delta y. Subtract these values and apply here cos p minus cos q, 2 sine p plus q over 2 and sine p minus q over 2. Cos p minus cos q, its formula is minus 2 sine p plus q over 2 and sine p minus q over 2. Now simplify these values, and when we divide by delta x, sine delta x over delta x is 1, and put the limit, and here we have the answer 2 sine 2x. Now in this question we have sine square root on angle, delta y becomes sine x plus delta x minus sine square root x. Now sine p minus sine q formula is 2 cos p plus q over 2 and sine p minus q over 2. Now here we have a product of these two values, x plus delta x plus square root x and x plus delta x minus square root x, a square minus b square, it is equal to delta x. Now we divide by delta x and we replace delta x by this value, and we divide by the lost angle by 2. We move the first 2 to the last value, and then limit delta x tends to 0. The last factor become 1, and we put limit in the angle of cos, and this is your answer, cos square root x over 2 square root x. Now in this question we have cot square. Delta y is equal to cot square x plus delta x minus cot square. We can write it as plus and minus a square minus b square, and a is equal to a plus b, a minus b. Only the negative values we can write these values. Cot is cos over sine, taking LCM, and its formula is sine alpha minus beta. So if we have negative in angle of sine, we move into the outer side, and then we put the limit. Sine delta x over delta x is 1, and the remaining values are simplified, and this is your answer, minus 2 cot x and cosecant square x. Now in this question we have differentiate sine cube x with respect to cos square x. We let these values, first is y and second is u. We differentiate y with respect to x and u with respect to x. Sine cube x is 3 sine square and derivative of sine is cos x. Derivative of base in u du by dx. Derivative of cos square is 2 cos and derivative of cos is minus sine. We apply chain rule. Now derivative of inverse trigonometric functions. Derivative of sine inverse is 1 over 1 minus x square and derivative of cos inverse we only put the negative sign, and sine inverse and cos inverse derivative is same, only negative sign, change their values. And derivative of tan inverse x and derivative of cot inverse x also same. Here we have also note that the value with the function which start with the letter C, its answer is negative and other answer are positive. These are their domain important for the objective. Now we prove sine inverse formula. We let y is equal to sine inverse x. We move sine to the left hand side, it becomes sine y is equal to x. Now differentiate these values. Derivative of x is 1 and derivative of sine y is cos y and derivative of angle is dy by dx. Again we divide cos y to the left hand side, it becomes 1 over cos y, and we can write cos y is equal to 1 minus sine square, because cos square plus sine square is equal to 1 and cos square is equal to 1 minus sine square. Because we have no square on cos, therefore we write square root 1 minus sine square, and sine y is equal to x. We put this value here, so derivative of sine inverse x is 1 over 1 minus x square square root. Now we find the inverse derivative of cos inverse x. We move cos to the left hand side, it becomes x is equal to cos y. Derivative of x is 1 and derivative of cos is minus sine y and derivative of angle is dy by dx. We can write sine y is equal to 1 minus cos square. Again the property sine square plus cos square is equal to 1, so sine square is equal to 1 minus cos square. And cos y is equal to x square. Now to find the derivative of tan inverse, tan y is equal to x. Now differentiate these values. Derivative of x is 1, derivative of tan is secant square and derivative of y is dy by dx. Now we divide secant square to the right side. Secant square is equal to 1 plus tan square and tan is equal to x. Therefore the answer is 1 over 1 plus x square. So inverse derivative of cosecant inverse, so it becomes cosecant y is equal to x. Derivative of cosecant is minus cosecant cot y and derivative of angle is dy by dx. So dy by dx is equal to 1 over cosecant y cot y, and we can write cot y is equal to cosecant square minus 1. We have formula for cot square is equal to cosecant square minus 1. We put these values and cosecant y is equal to x, so the answer is minus 1 over x square minus 1. So here we have example. Y is equal to x sine inverse x over a and a square plus x square. In first factor we apply product rule, and in second we apply power rule. Now here d by dx of x sine inverse x over a plus a square plus x square. Now we apply on each value d by dx x sine inverse x over a and d by dx of a square plus x square whole power 1 by 2. Derivative of x is 1 and product rule we apply here, and x is same and derivative of sine inverse is, because derivative of sine inverse is 1 over 1 minus x square, we put x over a in formula, and derivative of x over a plus derivative of a square plus x square 1 over 2, it becomes power minus 1 and derivative of base. Now we simplify. Derivative of x over a is 1 over a, and here derivative of a square is 0 and derivative of x square is 2x. Now we simplify the square root value in denominator. We take a square LCM, and LCM is a square. When we move out from the square root, it becomes a. We note that the last two values are same. We got these values and the answer is sine inverse x over a. Now in this question we have y tan 2 tan inverse x over 2, and we prove these value d by dx is equal to 4 1 plus y square over 4 plus x square. Here we let the angle is equal to u, so the value become y tan u. dy by du is equal to derivative of tan secant square u, and we can write secant square is equal to 1 plus tan square, so it becomes 1 plus y square, and derivative of u is derivative of tan inverse. Tan inverse derivative is 1 over 1 plus x square. We replace x by 2 and derivative of x over 2. Simplify these values, and at the end we apply chain rule and put these values. Okay student, solve these examples and proofs, and if you have any problem then send it to me. Allah Hafiz. Jazakallah.